Hello everyone and welcome to our presentation. Let us start off by introducing ourselves. The authors of this research paper are Professor Koichiro Ishikawa, Mr. Sovannara Srun, and me, Sokol. We are from the University of Fukui, Japan. I will present some parts and will turn the rest over to my co-author, Sovannara Srun. So our talk today is about design and construction of reciprocal frame made of bamboo with connection by means of PVC pipe and rope. In this study, we aim to combine the special characteristics of the reciprocal structure and bamboo to propose a basic design of reciprocal dome as a temporary emergency shelter. The purpose is to explore the feasibility of realizing bamboo reciprocal dome by means of low technology connection with high workability construction method. Bending strength experiment of bamboo and structural analysis of reciprocal dome are carried out to investigate the load carrying capacity of the dome. The geometrical shape of the reciprocal dome is generated by configuration processing of Formian. Next, I'd like to give you an overview of the strength measurement of Moso bamboo due to bending moment. First, I'll start off by talking about the measurement of cross-section of Moso bamboo cones. The test specimens are for green Moso bamboo cones of more than 3 years old. As you can see in figure 2, we get the specimen pieces by showing the central sections of the internode and measure the cross-sectional dimension at the base opening side of the specimen piece. The result, combining the data of previous study, is shown in figure 3. We can see the proportional relationship between the internal diameter and the external diameter. It shows that internal diameter is 81% of external diameter. Therefore, the cross-sectional performance such as cross-sectional area, cross-sectional modulus, and so on of the Moso bamboo cones can be estimated in terms of external diameter. Here I'd like to move on to experiment on bending strength of Moso bamboo cones. The test specimens are 3 green Moso bamboo cones of more than 3 years old. The bending test was performed by a 3-point bending method as shown in figure 4. The result, combining the data of previous study, is shown in figure 5. We can see a strong correlation between the external diameter and the maximum bending moment Mmax, and also the bending stiffness EI. In other words, the rigidity and strength, which are a necessary input data for the structural analysis, could be estimated with relatively acceptable accuracy in terms of the external diameter. This shows a real possibility of bamboo temporary structures for the design in safety against external loads, such as a wind load, a snow load, and so on. So, next I'll let my co-author Sovannara Srun to finish the rest of presentation. Thank you.
Hello everyone, I'm Srun Sovannara and I'm going to take over from here. Move on to the determination of the final configuration of the dome. First, we need to determine the unit. Here are the parameters that will be used in configuration process and structural analysis. The units shown here are morphologically generated from elementary configuration by means of bending functions, and they are structurally analyzed. It shows here that the maximum bending moment of a unit is almost the same. In this study, the proposed dome is made of a 3-member unit in consideration of cost and workability. Next, I would like to introduce to you the bamboo reciprocal dome. The morphology is created with the same method as the previous slide by changing only the elementary configuration. This video shows elements transforming into mixture by GA using the same parameters. In order to confirm the morphology dome, we also constructed the full-scale bamboo reciprocal dome. The 3-member reciprocal frame is composed of PVC pipe and rope as shown in figure 10. The position of the hole can be determined based on bamboo's condition. Eccentricity is fixed by the rope that hold the member together. 4 holes will be drilled through each bamboo, and PVC pipe will be inserted as shown in figure 11. The reciprocal domes require 35 members in total. We aim for an easy construction method, and this construction requires only 2 hours and a half to complete, with only 2 builders without any special equipment. To study the structural behavior of the dome subjected to vertical loads, the elastic structure analysis of the dome was performed based on the analysis condition. Young modulus and maximum bending moment was determined through the proposed formula here. The results show that the dome can carry up to 7.88 Newton of vertical load. In conclusion, there are significant correlations between internal diameter, maximum bending moment, and bending stiffness in respect of the external diameter. It is seen that the proposed connection method has high workability rate and low construction cost. Through the study, the structural characteristics can be found through proposed experimental formula. The form of the structure could be determined through configuration in Formian. Load carrying capacity could be calculated. For the future work, the usage of bamboo could be further expanded in terms of temporary buildings, especially reciprocal structure. Thank you for your attention.